Ionizing radiation is a form of radiation that carries enough energy to remove tightly bound electrons from atoms, resulting in the creation of charged particles or ions. This process of ionization can have profound effects on biological tissues and materials. Ionizing radiation is commonly associated with various medical, industrial, and scientific applications, as well as potential hazards such as radiation therapy, nuclear power generation, and nuclear weapons. Here are some key points about ionizing radiation. Types of ionizing radiation. Ionizing radiation comes in several forms, including alpha particles. Alpha. These are positively charged particles consisting of 2 protons and 2 neutrons. They have low penetrating power and can be stopped by a sheet of paper or even human skin. Beta particles. Beta. Beta particles can be either electrons, beta, or positrons, beta plus. They have greater penetrating power than alpha particles but can be stopped by materials like plastic or a few millimeters of aluminum. Gamma rays. Gamma. Gamma rays are electromagnetic radiation similar to X-rays, but with much higher energy. They are highly penetrating and require dense materials like lead or several centimeters of concrete to attenuate. X-rays. X-rays are also electromagnetic radiation, but they are typically generated artificially using X-ray machines. They have similar properties to gamma rays and are used extensively in medical imaging and industrial testing. Sources of ionizing radiation. Natural sources. Ionizing radiation is naturally present in the environment. The primary natural sources include cosmic rays, radioactive materials in the Earth's crust, and radon gas. Artificial sources. Human activities have created various artificial sources of ionizing radiation, including medical X-ray machines, nuclear power plants, and particle accelerators. Biological effects. Ionizing radiation can damage living organisms at the cellular level. Depending on the dose and duration of exposure, it can cause acute effects, immediate health effects, such as radiation sickness, burns, and acute radiation syndrome, ARS. Long-term effects. Increased risk of cancer, genetic mutations, and tissue damage that may manifest years or decades after exposure. Units of measurement. The sievert, SV, is the international unit for measuring the biological effect of ionizing radiation. It takes into account the type of radiation and its energy, as well as the tissue or organ being irradiated. The Gray, GY, is the unit for measuring absorbed dose, which quantifies the amount of energy deposited by ionizing radiation in a material. Protection and safety. Ionizing radiation exposure should be minimized, and appropriate safety measures should be taken when working with radioactive materials or radiation-producing devices. Personal protective equipment, shielding materials, and safety protocols are used to reduce exposure to ionizing radiation in various industries and medical settings. Medical applications. Ionizing radiation is widely used in medicine for diagnostic purposes, X-rays, CT scans, and cancer treatment, radiation therapy. The goal is to target and destroy cancer cells while minimizing damage to healthy tissue. Environmental and regulatory concerns. Proper disposal of radioactive waste and safety regulations are essential to prevent environmental contamination and protect human health. It's important to note that while ionizing radiation has significant benefits in various fields, its potential hazards require careful management and monitoring to ensure the safety of workers and the general public. Regulatory agencies in many countries enforce strict guidelines to control ionizing radiation exposure and protect public health.